Good morning, students. So today, as we have discussed, I am taking complementary angles, trigonometrical ratios. Okay, I am just continuing the session from here. Okay, so let me zoom a little. Yes, I think it's visible to you. Yeah, perfectly fine. So, as we have discussed, okay, that any trigonometrical ratios for any right angle triangle which is covering an angle theta, and if one is a right angle triangle, then the third angle will be 90 minus theta. Okay, if this angle is theta, right, then this third angle, this one, will be equal to 90 minus theta. This will be equal to 90 minus theta. That we need to remember, because the sum of all angles of a triangle is 180 degree, right? And as we discussed that the angle and the another angle, the sum of two angles will be said to be complementary when the sum of both will be equal to 90 degree, right? So here we have discussed, okay, that if another angle, one angle is theta, then its complementary will be 90 minus theta, and when you add, you can see theta theta will be cancelled and LHS will be equal to RHS, which is equal to 90, right? So angle and its complementary is always equal to 90 degree, right? Now, as we discussed, right, that sine 90 minus theta is cos theta. How? Because if you take the 90 minus theta, this angle, and sine of 90 minus theta will be equal to b by h, which is the value of cos theta. So we can say that sine 90 minus theta is cos theta, right? This is, this can be said, this one, because this value is equal to b by h, right? Similarly, you can see cos Sin 90 minus theta is equal to cos theta, as we have said. And if you take cos 90 minus theta, right? If you take cos of this 90 minus theta, this will be how much? Then angle of consideration will be this one. Then cos of this will be, B will be the perpendicular and P will be the base, right? Here. So cos of 90 minus theta will be equal to P by H. P by H, right? And P by H is the value of, when you consider for this theta, this is the value of P by H is the value of sin theta. You can see here. So we can see that cos of 90 minus theta is equal to sin theta, because both of these values are equal to P by H. So the concept of complementary angle shows you that when you take the sine of any angle, then cosine of 90 minus theta will be equal to that. So let me summarize it in this way, okay, that if you write sine theta, it can be written as cos 90 minus theta, right? If you write cos theta, it can be written as sine of angle 90 minus theta, that is, it's complementary. All these angles 90 minus theta are complementary angles, right? These are the complementary angles, right? So here similarly we can write that tan of theta is equal to, and this will applicable to vice versa also, my dear friends, okay? For tan of theta, it will be equal to, which angle will be the complementary for this tan theta? 90 minus theta. For cot, so tan theta equal to cot of 90 minus theta. And sin cos tan is applicable, Now the reverse of sine will be cosec. So for cosec theta is equal to sec 90 minus theta, and likewise. So if you want to check any more, you can see that if you take the cosec theta from this triangle, cosec theta is how much? Cosec theta is h by p. H by p. Cosec theta is nothing but it's equal to h by p. This cosec theta is equal to h by p, right? Is it fine? This is equal to h by p. And what is the value of sec 90 minus theta? If this is 90 minus theta, my dear friends, then sec of 90 minus theta will be equal to, because this will be the angle theta into consideration, and cos of 90 minus theta will be equal to p by h, then sec of 90 minus theta will be equal to h by p. H by p, right? This is equal to the value of sec 90 minus theta. So for all complementary angles, all the complementary angles are related in the same fashion, and we are having these observations. We are having these observations, right? Now, let us take few questions so that you will be able to understand more and more clearly. Okay. So let me take the first question for today's session. This was the background, and into the first question we will start. So the first question for today: what is the value of cos 48 minus sin 42? Cos of 48 degree minus sin of 42 degree. If such questions are coming to you, my dear friends, did not to panic, just recall these complementary angle concepts. Okay, how they are related. Okay, sum of angle and its complementary is always equal to 90. Just remember this, right? Now, if you take this angle of 48 degree, okay, and this 42 degree, just think it. Just see these angles. You can see 48 plus 42. What is it? You can see it's 90 degree. That means this 48 and this 42, the pair of these angles are complementary. That means these angles 48 and 42 are complementary. So now we can use this concept. You can either use for 48 or 42, but any of these angles can be changed into its complementary, right? If you consider 48 as it is, then this cos 48 can be written at as it is and minus sine 42. Just convert this 42 into its complementary. When 42 is converted into its complementary, 42 can be written as 90 minus this 48 will be going to the RHS, right? So it will become, just write sine as it is, because sine of 42, in place of 42 write its complementary, that is 90 minus 48. You got it? What we did, we simply just converted the second angle into its complementary, right? So this will give you cos 48 as it is, right, minus sine of 90 minus 48. Sine of 90 minus 48, just see this, sine of 90 minus theta is cos theta, right? We have already seen the proof of that. So cos theta will be the value of this. So theta over here is 48. So it will become cos 48. And you can see cos 48 minus cos 48. Definitely both of these will be cancelled and our result is equal to nothing but 0. Right? Now, if you want, we can take another question. Let us make our concepts clear for these complementary angles. Okay? So, in the second question, we'll take some good questions for discussion today. The question number 2, cos square 13 minus sin square 77. It's cos square 13 degree minus sin square 77 degree, right? Again observe these two angles 13 and 17. When you add 13 with 17, we'll get answer equal to 90 degree. That means you know that these angles 13 and 17 are complementary. Without having any second thought, directly go and convert one of the angle into its complementary. Then we can write it as cos square 13 degree, right, minus sin square of not 77. It's complementary. Its complementary will be 90 minus 13. If you 90 minus 13 will be 77, right? Such questions are given into that way that you can easily set the another angle into its complementary, and the theta 90 minus theta, that theta will be equal to the previous theta for the first one, first ratio. Okay, how I am showing you in every question. This is very easily just set on that. So sin square, it can be written as 90 minus theta. So it is 90 minus how much? Complement 77's complementary is 90 minus 13. So just write it 90 minus 13 degree. Right? So here you can see this. If you add 90 minus 13 and 13, it will become, if you add 13 and 90 minus 13, the sum will be equal to 90 degree. Right? Because 13 and 13 will be cancelled out. Right? Now, simply, we know that sine of 90 minus theta is cos theta. A minus sign is already there in between. Sine square theta. So sine square 90 minus theta is cos. Leave a square as it is. Sine 90 minus theta is equal to cos theta. And theta is 13 degree. And a square is there onto the top. So it will be cos square 13 degree. And here we have already cos square 13 degree. So cos square 13 degree minus cos square 13 degree will be how much? This will be cancelled out and your answer is equal to 0, a big 0, right? So in this way we can see such questions can be solved. Let me take some more a little tough question, or maybe where you can apply more concepts. Sine 43 degree, cos 47 degree. You can see 43, 47. If you add, it's become 90, complementary. Plus degree. Sine of 47 degree. To prove this, all is equal to 1. We need to prove. We need to prove it. Right? So students, you can easily see. my dear friends, that 43 and 47, when added together, it becomes, you can see, 43 plus 47 is nothing but equal to 90. Similarly, it happens over here also, 43 and 47. So these are the complementary angles, you can easily judge it, right? When you judge it as complementary, then what we will do, we will simply convert, leave one of the angle, don't convert both the angles into its complementary, it will become a trouble. You will state with the status will be same again. So just leave one of the and convert another one into its complementary. So if you leave sine 43 as it is and convert this cos 47 into its complementary, this 47 into its complementary is becomes 47 when converted into its complementary, it becomes 90 minus 43, isn't it? 90 minus 43, right? Plus, so plus sign is there, cos 43 sine 47. So here we are going to use the identity sin square theta plus cos square theta equal to 1. So if you are converting, if you are considering theta as 43 over here, then into the second one also you can consider theta as 43. So leave cos 43 as it is, right? So it become cos of 43, cos of 43 degree multiplied with sine of not 47 but its complementary. Write the complementary of 47. Complementary of 47 is 90 minus 43. So write it, 90 minus 43. Right? As we did it for the second term of the with sine 43. Okay? So it will become sine of 43 degree multiplied with cos 90 minus theta is how much? Cos 90 minus theta is sine theta. So it becomes sine 43 degree plus cos 43 degree and sine 90 minus theta is cos 43 again. So it becomes cos 43 degree. So cos 43 is coming two times, right? Cos 43 is coming two times. So we can write it as cos square 43 degree. And sine 43 is coming two times. So we can write it as sine square 43 degree. So you can see sine square theta plus cos square theta, where theta is nothing but 43 degree. Then what is the formula if you recall? Sine square theta plus cos square theta is always equal to 1. Is always equal to 1. So here theta is nothing but it's equal to 43 degree. Right? So the above expression sine square 43 plus cos square 43 is equal to 1. And hence we have proved this as equal to 1. Right? So sine 43 cos 47 cos 43 sine 47 is equal to 1. Right? Let me say take some different question. Similarly, we have question number 4 for today. Tan of 48 degree multiplied with tan of 23 degree, then tan 42, then tan 67. What is the value of this? we know that 48 plus 42, this become complementary, right? 48 plus 42, this is coming as equal to 90. Similarly, this 23 and 67, this is also coming as equal to 90. So into such questions, we need to make sure that one of the angle, leave it as it is and convert the another one into its complementary. So here the pair of tan 48 and tan 42 should be there. Okay, so we can make a pair like this: tan 48 into tan 42 into one bracket, and tan 23 and tan 67 into as another pair. So it will be tan 23 into tan of 67 degree, right? The benefit of that is tan 48, keep it as it is and convert the another angle into its complementary. So it becomes tan 90 minus 48. So tan 90 minus 48, right? Multiplied with tan 23 multiplied with tan of 90 minus 23, which is equal to 67 degree, right? So here you can see tan 48 will be as it is. Tan 48 will be as it is. You can leave it as it is. And tan 90 minus theta is cot theta. So it will become cot 48. Similarly, for the second one, I think it's not very much clear. Let me hold it from my hand. Okay. So you can see tan 48 and tan 90 minus 48. Tan 90 minus 48 can be written as cot 48. Right? It can be written as cot 48. So this will give you, if you see the pair, tan 48 into cot 48, if you keep it in one bracket, and similarly tan 23 and tan 90 minus 23. So it becomes tan 23 and tan 90 minus 23, that is its complementary, is cot of 23, right? Just keep it into another bracket. And now we can see tan 48 and cot 48 will be cancelled out. And this will give you 1. Multiplied with tan 23 and cot 23. This will also be cancelled out. So this will be giving you 1 into 1, which answer is coming as 1. Right? Into the same series, there is a very good question: tan 1 degree, tan 2 degree, tan 3 degree, 4 degree, 5 degree, like that. And we need to find the value of that. So let us solve that question. The question, we have already solved question number 4 questions till now. So let us take question number 5. So the question number 5 for today. We need to prove that tan of 1 degree multiplied with tan of 2 degree multiplied with tan of 3 degree multiplied with dot 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 multiplied with tan of 89 degree as equal to 1. This as equal to 1. So students, as we learned into the complementary angle concepts, you can see here 1 degree, 2 degree, 3 degree till 89. Because tan 90 is not given over here, because if all are in product and tan 90, you know the value of tan 90, it's infinity, right? So here we see that all these angles, all these angles need not to be evaluated, but we are going to use the complementary angle concepts here. How? 1 degree and 89 degree. When you add, if you write 1, 2, 3, 4, then again, and from here if you reverse it, just count it, 86, 87, 88, 89. All these are the angles, 1 degree, 2 degree, 3 degree, 4 degree till 85, 86, 87, 88, 89. So what you will see, when you just 1 with 89, it will form a pair of complementary angle. When you just 1 with 89, it will form a pair of complementary angle. If you add 2 with 88, it will form a pair of complementary angle. 3 with 87 form a pair of complementary angle. 4 with 86 will form a pair of complementary angles. Right? So what we will do, we will make a pair of 1 degree and 89 degree together. That means tan of 1 degree, this one, and tan of 89 degree, this will be taken together. Right? So what we will do, tan of 1 degree, since all are in product, just write it as it is, into tan of 89 degree multiplied with, take the another pair, 2 and 88. That means we have already taken tan 1, tan 89, then come to tan 2 degree. So tan 2 degree with its pair from second from the last. This is before tan 89, it was tan 88 degree, right? So take this tan 88 with tan 2, right? So tan 2 degree into tan of 88 degree. You can see 2 and 88 both are complementary, right? So we are using the complementary angle concepts over here, and just make a pair of such angles which are complementary. Similarly, tan 3 degree and tan 87 degree. Again, tan 4 degree, tan 86 degree. Like that. So when you go to last, right? When you go to last, till tan 44, if 4 is there, let us see, if you go to tan 44 degree, from the reverse side, you are having tan 46, because 44 plus 46 is 90. This 44 plus 46 is 90. Then one angle is left in between, because we From here you can see we covered 1, 2, 3, 44, and also after 45 we cover from 46, 47, 48 till then 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, right? So you can see these pairs 189, all these pairs are complementary, right? So we can write tan 1 and tan 89 as, this can be written as, just if you show it, tan 1 degree, and tan 89 can be written as cot 1 degree, because tan 90 minus 1, 90 minus 1 degree is tan 89, so it will be cot 1 degree. This will be tan 2 degree into cot 2 degree. This will be tan 3 degree into cot 3 degree. This will be tan of 4 degree into cot of 4 degree, right? So what is the benefit of here is that when the angle is converted into its with its complementary multiplied with, then you can see tan 1 and cot 1. You know that tan of theta is equal to cot of 90 minus theta, right? So here you can see tan 1 and cot 1 will be cancelled out, tan 2 and cot 2 will be cancelled out, tan 3 and cot 3 will be cancelled out, tan 4 and cot 4 will be cancelled out, and here again tan 44 and cot 44 will be cancelled out, right? If I will write, then we can see tan 44 and this tan 46 can be written as cot of 44, right? So this will also be cancelled out. So into the last only on one angle will be left, that is equal to tan of 45 degree, because you can see 1, 2, 3, 4 till 44, 45, 46, 47 till 80, 81, 85, 86, 87, 88, 89. So all these angles are covered, right? So only one angle is left, tan 45, and the value of tan 45 is 1, and all this is already cancelled out. So we can write all this as equal to 1 into 1 into 1 into 1, 1 into 1 into number of 89 times, it's 44 times it's coming, and this tan 45, this is 1. So all this is equal to all 1 multiplies together will give you the result as 1, right? And in this way we proved this, that yes, tan 1 degree, 2 degree, 3 degree till tan 89 degree is 1. So this is the concept of complementary angle, my dear friends, and we can use it. If you want me to take more questions, I will take more. It's given that sec of 5a is cosec a minus 30. Find the value of a. This is the question number 6 for today. That if you have taken, if given that sec 5a equal to cosec a minus 30, then find the value of a, and a is an acute angle, right? So if you remember the concept of complementary angle, right, that if sec theta written in terms of cosec theta, we can write at sec theta as cosec 90 minus theta, isn't it? Now cosec 90 minus theta, we can write it. So where theta is nothing but the angle which is with sec, right? So you can see these angles should be complementary. That means 5a and a minus 30 should be complementary. So here we can see, if you can write, if these angles are complementary, then we can write 5a, plus a minus 30, all this will be equal to 90 degree, right? Using the complementary angle concept. So from here we can see 30 gone into the RHS, this will be giving you 6 times a left into the LHS is equal to 90 plus 30, right? So this will give you 120 degree as the value of 6a, and finally you get the value of a as equal to 120 degree divided by 6. So the value of a is coming as 20 degree. So the value of a is calculated as 20 degree, right? So this is your answer. We can take more question, my dear friends. So what is the concept of complementary angles? How to solve such questions? You know it, right? Now, let me take question number 7, maybe from the exercises. Okay. Let me take question number 7 for the today's series. It's given that sine 70 degree by cos 20 degree plus cosec 20 degree by sec 70 degree. You can easily observe 20 70 complementary, 70 20 complementary, minus 2 times cos 70 cosec 20 into cosec 20 degree. All this is equal to 0. We need to prove it. So students, sine 70 can be written as it is, and cos 20 is written as cos 90 minus 70. So that is equal to sine 70. I am directly writing it because 20 and 70 are complementary. So we can write cos 20 as cos of 90 minus 70. So that is sine 70. So I'm just, now we have done a lot of exercises, so I'm directly writing it, this cos 20 as sine 70, right? Now for the second one, it's cosec 20, leave it as it is, and 20 and 70 are complementary. So sec of 70 degree can be written as sec of 90 minus 20, which can be written as cosec 20. So here also the denominator is cosec 20 degree, right? The benefit of this is that sine 70 will be cancelled out, we are 1, plus cosec 20 will be cancelled, we are having 1. So 1 plus 1 is 2, right? Minus Here you can see 2 times cos 70. So it is 2 times cos of 70 degree and cosec 20 degree. Cosec 20 degree can be written as 1 by sin 20 degree, like this. This will give you 1 plus 1 is 2 minus 2 times cos of 70 degree divided by sin 20, and sin 20 is nothing but sine of 90 minus 70 degree. This will give you 2 minus 2 times cos of 70 degree divided by, you can see it's complementary, sin 90 minus theta is cos theta. So this is equal to cos 70 degree because theta is 70. Here also cos 70 and cos 70 will be cancelled out. So we are left with 2 minus 2, 2 minus 2, which is equal to 0. In this way we have proved that the above expression is equal to 0. Right? So I think students, we have already solved such many questions of complementary angle concepts. There is a good question which I have already put into my shorts. There is a triangle. If ABC are the angles of the triangle, this is question number 8 for today's series live class. This is a right angle triangle, let us say. No, it's not given that a right angle triangle. It's given that A, B, C are the angles of a triangle. Angles of a triangle A, B, C. So if A, B, C are the angles of the triangle, prove that, what to prove? Tan C plus A by 2, tan of C plus A divided by 2 is equal to cot B by 2. This we need to prove. This we need to prove. So students, into this question is given that A, B, C are the angles of a right angle angles of a triangle, not a right angle triangle. This is not given to you. So from here we can see that if ABC are the angles of a triangle, then the sum of all angles of any triangle, we know that it's 180 degree. So angle A plus angle B plus angle C, all this will be equal to 180 degree. Just remember this concept, nothing more than that. It's very easy question. A plus B plus C is equal to 180 degree because it's a triangle. Everyone knows it, right? Now C plus A, here it's C, here it's A. So C plus A will be how much? You can see here C plus A can be replaced as 180 minus B. So we can write LHS as equal to tan of C plus A can be written as 180 minus B. 180 minus B whole divided by 2. This will give you, if you divide both the term inside the bracket separately, you get tan of 90 minus B by 2, isn't it? This will give you tan 90 minus theta is cot theta, that is cot of theta, and theta is nothing but B by 2. So it's cot of B by 2, which is the value of your RHS. In this way, we have proved that tan C plus A by 2 is equal to cot b by 2. So this is proved. Tan c plus a by 2 is cot b by 2. Proved. So thank you so much for watching, students. I think with this I can close today's session and we'll come up with. No, I know the topic for today is little bit easy for many of you, but yes, the concepts are very much important. Then we will gradually go into the a more in-depth concept application of these complementary angle concepts, right? And thank you so much for being watching. Be connected. Take care. Bye bye. See you.